we are taking a look at solving linear systems algebraically. So once again, we're finding the solution to linear equations instead of graphically, which we looked at yesterday. And the day before, we'll be looking at solving algebraically. So we're looking for the ordered pair that is a true statement, that produces a true statement for both linear equations. First, we're going to take a look at the vocabulary. The substitution method. Your first step is you solve one of the equations for one of its variables. Second, you're going to substitute the expression from step 1 into the other equation and solve for the other variable. Your third step, you're going to substitute the value from step 2 into the revised equation from step 1 and solve. And then you have your solution. Once again, with the solution, you can always go back and check those. For the elimination method, our first step is to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. Then you're going to add the revised equations from step 1 and solve for the remaining variable. Your third step is to substitute the value obtained in step 2 into either of the original equations and solve for the other variable. So let's take a look at some practice problems. The first equation we have, we're going to solve this by using the substitution method. So that first method we looked at in our vocabulary. So solving using our substitution method. Now, the big thing with solving with the substitution method is you need to identify which variable you're going to solve for. Now, the variable you want to end up solving for is the one, if you have one that has a leading coefficient or a coefficient of 1. Now this y value has a coefficient of 1, so I'm going to solve for y. So I'm going to subtract 3x from both sides. I get the equation, those cancel out, y equals negative 3x plus 5. Now our second step is to substitute this value into the other equation. It has to be the other equation. It can't be the same equation. So I'm going to substitute negative 3x plus 5 in for y, so into that first equation. So that will give me 6x plus 3, then open parentheses, and when you're substituting, you want to get in the habit of opening parentheses. So negative 3x plus 5 equals 12. Now we have a system and one variable equation to solve. So we have 6x. We're going to distribute the 3 to this binomial. So 3 times negative 3x is negative 9x. 3 times 5 is plus 15 equals 12. We're going to combine our like terms. 6x minus 9x is negative 3x plus 15 equals 12. And now we have a two-step linear equation. So we're going to subtract 15 from both sides. Get negative 3x equals negative 3, and divide both sides by negative 3. So we get x equals positive 1. So we have that x coordinate. Now in order to find that y coordinate, we can substitute x equals 1 into this revised equation that we wrote for step 1. So, and it's also in terms of y, so that's nice. So we have y equals negative 3 times 1 plus 5. Once again, when you're substituting in, it's a good idea to get in the habit of writing what you substitute in parentheses. Negative 3 times 1, we get negative 3 plus 5, so y equals 2. So our solution here, keep in mind it's an ordered pair, it's our x value 1, comma, our y value 2. So our solution is 1, 2. And once again, if you want to check this, you can substitute this equation or this solution, 1 for x, 2 for y, into both equations, and it will produce a true statement. Now, since we have one solution, our system here is consistent and independent. All right, let's take a look at elimination. All right, we're solving by elimination. Now, To solve by elimination, we need to make sure the coefficients of one of the variables are the same but opposite signs. Now for this one, the y, the coefficient here is -3, and this y's coefficient is +3. So we're looking for opposites that when we would add them together, they're going to cancel out. Since these are the same value but opposite signs, -3y plus 3y is 0, so they eliminate each other. And then we add the remaining factors, or terms. 6x plus, keep in mind this is 1x, is 7x. 12 minus or plus -5, so you can get 12 plus -5 or 12 minus 5 is 7. Divide by 7, and we're left with x equals 1. Now this one, the first step was already done for us, so we moved on to that second step. So our third step, we substitute in 1 and for either equation to solve for y. I'm going to substitute into the second equation. So I get 1 plus 3y equals -5. This was to be 1 plus 3y equals -5. Subtract 1 from both sides. Get 3y equals -6. Divide each by 3, so y equals -2. So our solution here is 1, -2. Now once again, since we have one solution, if we substitute 1 in for x, 2 in for y to produce a true statement in both of these, we have a system that is consistent and independent. All right, let's take a look at a next example. Solving the system using substitution or elimination. Now, on a test or a quiz, I'm going to let you choose which way you solve it algebraically. You'll just see the directions. The directions will say solve the system algebraically. So you'll be able to choose whether you do substitution or elimination. And then we're going to classify the system as consistent and independent or consistent and dependent. All right, so let's take a look at this one. Now, we want to favor substitution when we have a coefficient of 1. Now here we have a coefficient of -1, but not 1. So substitution would be a good option. But let's also take a look at elimination. Elimination, we want the coefficients to be the same but opposite. And this one, this 3 is pretty close to 6, but I would need to multiply it by -2 in order for it to be the opposite. So I would need -6. Now with elimination, there are infinitely many ways you can solve them, which is the beauty of it. So you may solve it differently than your neighbor, but you can still obtain the same answer. So for here, I'm going to be using elimination. I know 3x times -2 will produce -6x, and I'll be able to cancel those out. So when you multiply, you're going to multiply both sides by that value. So I'm multiplying both sides by -2. -2 times 3x is -6x. That's our first step. -2 times -x is +2y. And that equals 5 times -2, which is -10. And it's helpful to put parentheses around it just to give you that indicator that you're multiplying that out. And then I'm simply going to write the second linear equation beneath it. So 6x minus 2y equals 10. So now we're on our second step. We're going to combine these values. 6x plus 6x, -6x plus 6x is 0. 2x minus 2y is, once again, we have a 0 here. And that equals -10 plus 10, which is 0. Now 0 plus 0 is 0. So this is our solution here. Now let's take a look at what this means. We want to ask ourselves, when does 0 equal 0? It's always true. So since the 0 always equals 0, and it's always true, we have infinite many solutions. So for this problem, since we have infinitely many solutions, this is a consistent and dependent linear system. Now, if you get to this point and you get an answer that is never true, for example, if you got 2 equals 4, then that would be no solution, and it would be an inconsistent system. We'll be taking a look at that particular one together. Let's go to our last one, a word problem. Your school sells t-shirts that cost the school $5 each, or short sleeve, and they sell them for $8 each. Long sleeve t-shirts sold for $7 each and sold for $13 each. The school spends a total of $2,450 on t-shirts and sells them all for $4,325. How many types of each t-shirt are sold? First, we're going to write a system of equations. When we write a system of equations, we want to define that variable. Once again, as I said in the other one, I stick with x and y. So x I'm going to write as the number of short sleeve t-shirts. Y is going to be the number of long sleeve t-shirts. And the purpose of defining your variable, so when you get your answer, you know what that means. So first I'm going to represent the cost it costs the school to buy the shirts. So however many short sleeve shirts they buy, it's going to be 5 times x will be the total amount they spend on short sleeve. The amount they spend on long sleeve t-shirts will be 7 times y, the number of long sleeve shirts bought. So that equals 2,450. Now they sell all of them, so they're selling all the shirts that they buy, and they sell them, they end up making $4,325. Now for this one, we're going to be looking at that second bit of information. They sell each short sleeve for $8, so that's going to be 8x, plus the long sleeves, which will be 13y. So this is our system of linear equations. Now we need to solve. Now for this one, you can use either elimination or substitution. For this particular problem, I'm going to use elimination. I'm using elimination because I'm going to multiply both of these equations to make sure I have a coefficient that is the same but an opposite side. So I'm going to go with my leading coefficients here. So I am going to multiply this top expression by -8. So I'm just taking this coefficient and multiplying the numerator by that. And then I'm going to multiply the bottom equation by +5. Now you could reverse it. You could multiply the top by +8 and then multiply the bottom by -5. But I'm just taking the opposite coefficients because when I multiply them together, I'll get the same coefficient. Alright, so I'm going to write that answer down here. So we'll get -40x, I'm going to distribute that out, minus 56y equals -19,600. So distribute that 8. Then our next line, 5 times 8, I get 40x, 5 times 13y, plus 65y, and that equals 21,625. And now I can use elimination. I can cancel out my x value, and I have -56y plus 65, which will give me 9y. And that will equal, when I combine these, 2,025. I'll divide both sides by 9. So y equals 225. So now I have my y value. Now to find the x value, I can substitute 225 into either of the original equations. Now you can also substitute them into one of these new equations that we multiplied, because they would be the same. These are just, the original ones are simplified, but I'm going to use the smaller numbers. And I'm going to substitute it into that first equation. So get 5x plus 7 times 225 equals 2,450. The next line, we'll get 5x plus 1,575 equals 2,450. And I'll subtract 1,575 from both sides. I'll get 5x equals 875, divide by 5, so x equals 175. So our answer to this particular problem, the school sells, and once again x is the number of short sleeve, 175 short sleeve shirts, and y is the number of long sleeve, and 225 long sleeve shirts are sold. And that is the answer to that problem. We are done.